Hello, everybody. In this video, we're going to look at the quotient rule for differentiation. And the plan is really simple. We're going to state but not prove the quotient rule for differentiation. And then we'll work through 3 examples. So without further ado, here is the quotient rule for differentiation. If you have a quotient of functions, let's call the numerator a function f and the denominator function g, and you know that f and g are both differentiable at the argument x, and the value of g at x is not 0, then the derivative of this quotient is going to be equal to this expression here. G of x f prime of x minus f of x g prime of x over g of x quantity squared. That's the quotient rule. It looks a lot more complicated than the sum rule or even the product rule. And some people have poems to help them remember this, or they're good at remembering formulas. If it's at all worthwhile, I'll give you what I use for a mnemonic device. If it's not useful, just ignore it. But I like to think of the function f of x over g of x as sort of living in a house. And you could go in on the ground floor of that house, and you'd encounter the function g, and then you move upstairs times the derivative f prime. Then you're going to change directions, and that's going to be indicated by your change of sign. And you're going to take the function in the top floor and bring it down and multiply it by the derivative in the ground floor, g prime of x. And now you're on the ground floor for the second time. And so g of x there in the ground floor position squared is what I think of there. And that's how I remember it. It's a little weird, but if it's helpful to you, great. If not, figure out a different way. But this is a formula that you really need to know. You're going to see a lot of quotients. For example, if you want to take the derivative of the tangent function, you realize the tangent function is by definition the quotient of sine over cosine. So we can use the quotient rule. This derivative is going to be cosine x times the derivative of sine x minus sine x times the derivative of cosine x, all over the denominator function squared, in this case cosine squared. Now we need to just simplify this, and we'll notice that the derivative of sine is cosine, so this expression just becomes cosine squared. And the derivative of cosine is negative sine, so actually this whole expression then becomes negative sine quantity squared, which is positive sine squared. So we'll add sine squared all over cosine squared. And the numerator, of course, adds up to 1. Cosine squared plus sine squared equals 1. So here we are, 1 over cosine squared, otherwise known as secant squared. And that's an important formula. The derivative of the tangent function is secant squared. Our second example, we'll take the derivative of this rational function, quotient of polynomials. So our pattern, again, is denominator function times the derivative of the numerator function minus the numerator function times the derivative of the denominator function over the denominator squared. Now let's notice that the derivative of both of these fourth degree polynomials is the same. It's 4x cubed. So we'll substitute that information in, and actually while we're at it, we'll just take the 4x cubed and factor it out all together. X to the fourth minus x to the fourth, those terms cancel, and 5 minus negative 5 would be positive 10. And we can just put everything back in the numerator there. So 40x cubed over the quantity x to the fourth plus 5 squared. And there's our second example. We're going to change gears here for the third example. Let's suppose that the differentiable function g is graphed here in this diagram. And now we're going to define a function capital F of x is equal to the quotient of the cubing function over g of x, x cubed over g of x. What is f prime of 3? So we need the formula for f prime of x generally, and for that we turn to the quotient rule. F prime of x is going to be g of x times the derivative of x cubed, or 3x squared, minus x cubed times the derivative of g prime of x, all over g of x squared. Now, we're interested in evaluating this when x equals 3. So we need to substitute 3 in for all the occurrences of x in this formula. So f prime of 3 will be equal to this expression here. We have just literally swapped out 3 for x everywhere in our formula. And so we need to know what g of 3 is to evaluate this, and we also need to know what g prime of 3 is in order to evaluate this expression. And for this information, we'll turn to the graph. And we can read off that g of 3 is equal to 2. And if we carefully draw a tangent line, and we pick a nice part of the tangent line by which we can calculate the slope, we notice that g prime of 3 appears to be 2/3. And so f prime of 3 is going to be 2 times 27 minus 27 times 2/3 over 2 squared. And now we'll just factor out the 27 and replace 2 squared with 4. And actually we can multiply top and bottom by 3. And we get this expression. 6 minus 2 is 4. 4 over 12, that's 1/3. 27 times 1/3, it's just 9. And so there you go. If f is this function here, this quotient of x cubed over g of x, then f prime of 3 is 9.